So welcome to the group, to Barcelona group. So the talk today, there's two talks. We will have two talks of 30 minutes each. And if you want a little bit of
30.
space between like 5 minutes to rest or go to the bathroom or something. And yeah, so I think that's it. Let's thank Edwin Solideo for the host.
We are hiring almost all the meetups. So if you know us, just apply. We have job opportunities in our web. So apply anytime you want. What?
Yeah. So you can start. So Ivetta will present the Coroutines experimental. So let's enjoy this amazing talk.
So guys, how many of you are working with coroutines? Okay, not such a big number, but it's not any problem. So, as you may know, Kotlin Coroutines has become a stable feature in Kotlin 1.3. Since then, we can finally get rid of the experimental flag and dive into the world of concurrency. However, there are still some experimental and obsolete declarations which may get changed or redesigned in the future. So for those who don't know me, my name is Ivetta. I am an Android developer at STRV, and I will guide you through this forthcoming part of the Coroutines API. So some of you might be wondering why you would consider using coroutines if we have threads. So what is the key difference between coroutines and threads? To answer this question, we need to go deeper to see how threads work at the very bottom level inside of our CPU. So this is our CPU, and let's say this CPU has 4 cores, so it's a quad-core CPU. Let's think about each core like a worker, and each worker does what the operating system tells him to do. So the operating system is like a boss who manages our co-workers. Threads are like sequences of commands given to cores. You can imagine them like assembly lines by which some products are delivered to workers to process. However, our workers are not the only one busy in this moment, because our operating system, the boss, is also fully included in the process. He has to manage all threads and take care of scheduling. Last but not least, threads are expensive, because on JVM each thread takes around 1 megabyte of memory. So now when we hopefully understand the general purpose of cores and threads, it's also important to understand the difference between a physical core and logical core. So a physical core is kind of what it sounds like. It's physically on the CPU, it's like the hardware of the CPU itself. A logical core is like code. It exists in the computer, but it's not bound to any particular hardware. The amount of logical cores expresses how many threads you can start at the same time. So if you have, for example, a computer with 4 cores and you can start 4 threads, that means that you have 4 logical cores and 4 physical cores. But if you have a CPU with 4 cores, but you can run 8 threads at the same time, you have 4 physical cores, but 8 logical cores. Now, what happens if you have more logical cores than physical cores? You can think about the situation like when a worker is responsible for 2 assembly lines. He cannot take care of both of them at the same time. So let's say he starts processing products from the first line, but then suddenly something happens, products are over, they are waiting for more products, whatever that makes the worker unable to work on the first line anymore. But let's say that products for the first line, for the second line, are ready to process, so the worker can take advantage of this gap, and instead of waiting, he can switch to the second line and process his products from there. And when he finishes his work, he can check if products for the first line are ready, and if they are, he can switch back and finish his work there. So now all work is done, the boss is happy, and the worker can go home earlier. The situation which we have seen at the beginning, when all workers are working at the same time and each of them is responsible just for one line, is what we call a parallel operation. But as we have seen, a core itself cannot work on multiple threads. If there are more threads to process, the core will switch among them. And this switching operation is what we call a concurrent operation. So it kind of pretends to be a parallel operation, but in reality, tasks are not executed at the same time, they are executed concurrently. And speaking about concurrency, we are now ready to start talking about coroutines. Conceptually, coroutines work like threads executing tasks concurrently. But unlike threads, coroutines are not bound to any particular thread. A coroutine can start executing on one thread, then suspend its execution and resume on another thread. Another important thing about coroutines is that while a coroutine is suspended, it doesn't block the current thread. When a coroutine reaches suspension will happen. And as you can see, now function frymeet and heatban were executed concurrently on the main thread. When summer holidays started, more people were coming, and I just wasn't able to manage the whole stand by myself. We needed more people and some hierarchy of responsibilities to handle long queues as fast as possible. So we hired more people, and we created 2 roles, cook and cashier. The role of cook was taken by me and my friend Dominika, and to take care about the cash desk and taking orders, there was Linka to help. We also needed to buy more appliances for each cook one, because otherwise we would have likely killed each other. So the situation looked as follows. Linka took an order, and the first available cook, let's say me, received a command to process the order. In a while, Linka took another order, and the first available cook, now Dominika, because I'm busy with the first order, received another command to process the new order. But then, both cooks became busy, so Linka had to stop taking more orders. She had to suspend until at least one cook became ready again. So now we have more coroutines. We have Linka, people, Dominika, and me, and we need to find a way how all these coroutines can communicate together. And that's exactly channel is good at. Our first experimental declaration, channel, experimental/obsolete declaration for now, serves as a communication medium which provides a way to transfer a stream of values between coroutines. Channel is conceptually very similar to blocking queue with 2 key differences. The first one is that instead of blocking put, it has suspending send, and instead of blocking take, it has suspending receive. Channel implements 2 interfaces, sender channel, represented by actor, which will be discussed later, and receive channel. Receive channel represents the producer-consumer pattern. So a producer produces values and sends them to the channel, and a consumer consumes values from the channel. So you can imagine a channel like a box or tube where all these values are stored for some time. Multiple coroutines may receive from the same channel, distributing work among the self. Each coroutine will have its own turn to receive a value from the channel. Same on the opposite side, more coroutines may send to this same channel without the worrying that one coroutine would exceed the whole channel's buffer. Because of that, we can rely on the fairness of channels while implementing both fan out and fan in operations. Work will be every time distributed fairly among all coroutines. So let's suppose that Linka is our channel, that she is a communication medium between people asking for hamburgers and cooks processing orders. At the beginning, all coroutines are active. There are no people asking for hamburgers, so that no orders to process. Then the first person comes and asks for a hamburger. The first available cook, let's say me again, receives a command to process the order. Therefore, I became busy, so I need to suspend so that I cannot take more orders until I process the one which I currently have. In a while, Linka takes another order, and now Dominika needs to take this order because I'm suspended, and she suspends as well. As a result, Linka needs to suspend too and stop taking more orders until at least one cook becomes ready again. However, when I finish my order, I can let Linka know that I'm ready, so she can become active again, start taking more orders, which I can process. But as you may know, nothing lasts forever, neither does our working day. In the evening, Linka just closes our window so that the channel gets closed, And that's a sign for people that it's time to leave, and also for cooks that they are free of work and they can go home. So let's check how we can implement this situation. We create a channel as a communication medium between people asking for hamburgers and cooks receiving orders. We launch a coroutine representing people, and inside, we create a coroutine representing people, and this coroutine is responsible for sending orders to the channel. And when we process our orders, we cannot forget to close the channel, because otherwise our program would be in a suspended state and it would never finish. As a next step, we launch 2 coroutines representing our cook, and we implement the fan-out operation. That's the one when more coroutines may receive from the same channel. Inside of both suspending lambdas, we pass the channel as an input parameter of make hamburger function, so that both coroutines may work with the same channel. And in make hamburger function, we just get orders from the channel by using a for loop, and we process each order by the way we have seen before. There are 2 ways how we can optimize this code. The first optimization is that instead of creating a channel by its constructor, we can use produce coroutine builder, which launches a new coroutine to produce a stream of values by sending them to a channel, which is then returned as received channel. The main advantage of this approach is that the channel gets automatically closed when the lambda inside of the builder is finished, so you don't have to think about it so much. The second optimization is that instead of the for loop, we can use extension function consume each, which does almost the same. It creates a for loop somewhere in the background, but this approach is not totally safe if we use more coroutines. Because with the for loop, when one coroutine fails, the second one is still able to process the channel. But with the consume each, it works differently, and consume each every time closes or cancels the channel on its normal or abnormal completion. And in our situation, we don't want to close the channel when an error occurs, because when a cook makes a hamburger with ketchup instead of mustard, it's not the reason to close the whole stand, right? So that's why we rather leave the for loop here. And let's run it again. So the first order was taken by me, the second one by Dominika, and when I finished the first order, I took the third order. Work was divided equally. First order was taken by me, then Dominika, me, and the next one will be taken by me as well, by Dominika. Yeah, because first one by me, Dominika, me, and then Dominika, yeah. And if we assume that making a hamburger would still take the same amount of time, that each cook would make the same amount of hamburgers because of the fairness of channels. So our business was doing quite well, so we decided to come with a special one-day offer. For every hamburger board, a beer for free. So we hired Monika to help us with tapping beers, and the situation worked as follows: that Linka took an order, the first available cook received a command to process the order, but right after, Linka asked Monika for one beer, and then the hamburger was served together with the beer to the customer. So let's first try to implement Monika by using a channel. In the produce coroutine builder, we just log a message that the beer is getting tapped, and when it's ready, we send the beer to the channel. In the main function, right after sending an order to cooks to process, first we create beers channel, and then right after sending an order to cooks to process, we ask for a beer from the channel. And just for now, let's just add a little bit more messages to see better what is happening inside. And let's run it. And can anybody see something different in this output?
Say coroutine instead of the name?
No, it's not the issue. It's just because I haven't added a name to the coroutine. But the issue is, if you can see, that the beer is getting tapped before the tab is ready. And the same thing is happening for the rest of the program as well, because each beer is actually getting tapped before an order was requested. And you know, if a beer was tapped and there was no order, then the beer will lose its phone. And I don't know how is it here, but in the Czech Republic, that's a really serious issue. And this is happening because channels represent a hot stream of values. Hot source is active even outside calling it. It can be active in the background before calling it, and it can be still active after calling it. So what is actually happening is this. We run the program, we log stand is opened, we create beers channel, but because channels are hot, all the code inside of the produce coroutine builder is executed. So a beer is getting tapped, and here we send the beer to the channel, and now the channel suspends until it has one receiver. Then the tap is ready, an order is requested, and a beer is received from the channel, so the channel is not suspended anymore, and it starts another cycle. And it suspends here again because no receiver has asked for one more beer yet. And again. So apparently channels are not good for this problem because they are hot. Every time the code is executed sooner than we actually need it. To represent a call source, there is another experimental declaration called flow. And flow supports called streams. A called flow is like a blueprint defining a computation. So nothing gets emitted nor executed until it is being requested for by a consumer. Flow has two main operations: emit, to send a value to this stream, and a bunch of terminal operators, which represents our consumers, our requesting consumers. Flow should be easy to understand for people familiar with RxJava because it works similarly. It has similar operators, but it just uses suspending principle. So let's change our code by using flow. First of all, we need to rename our function to beers flow. We need to call flow coroutine builder to create the flow. And flow doesn't have its active property because flow is not bound to any scope. Flow is cancelled where scope of its consumer is cancelled, or well, all requested values are consumed for the flow. Instead of send, we need to call emit. And because each subscriber gets its own copy of a flow instance, we need to move count variable outside of the builder block because otherwise it would be reset at each subscription. And flow on is a little bit advanced for this presentation, but what this basically does is that is switch flows context, similarly what subscribe on in RxJava does. And here I'm using it just for debugging principle because I would like to attach a name to this flow. In the main function, we replace beer's channel by beer's flow. We call take one operator on this beer's flow because we want to receive just one beer for each customer, and we call collect terminal operator to receive or collect all the values from the flow, and by this we also activate the flow's code. So now all the code inside of the flow is executed. And let's run it. And as you can see, with flow, Sundae situation. A huge group of people comes to the stand and they start asking for hamburgers all at once. So it's like 1 hamburger for me and 3 hamburgers for me, and you know what, I don't want 3 hamburgers, I want just 1 hamburger, and I change my mind, I don't want any hamburger, and etc. And Linka needs to take the final number of orders from this whatever shutting of people. And this is not a trivial problem because this number can be changed asynchronously by many people. And to be honest, Linka is not the most patient person in the world, so without any help, she would become crazy or make a mistake. Fortunately, Actor Hero is here to save the day, so our first obsolete declaration channel, actor, is the second type of channel implementing sender channel interface. You can think about actor like a mailbox. It receives values and it processes them as it needed. The real power of actor is to serve as a synchronization mechanism for coroutines in case you want to access a shared mutable object among more coroutines. The first step of using actor is to define which kind of messages this actor is going to process. So we will need to track quantity, so we create quantity counter message sort class with increment quantity to increment quantity, decrement quantity to decrement quantity, and get quantity to get the value of quantity. Completable deferred represents a single value that will be known in the future, and I'm using it here just to send the response back. We define an extension function that launches an actor by using actor coroutine builder. We define our shared mutable object and actor's reactions on these objects based on the message it receives. We need to somehow implement the massive order when all people are coming at once and when they start asking for hamburgers all at once. So we launch as many coroutines as people we have, and each person will ask request time to either create an order or cancel an order. The main code is then straightforward. We need just create the quantity counter actor. We need to launch the massive order with 8 people, where each person can ask 3 times to either create an order or cancel an order. After that, we get the final number of orders. And what is important is that actor has to be every time closed, no matter if it's created through its constructor or through actor coroutine builders. That's a really important difference between produce coroutine builder creating a receive channel and actor coroutine builder creating actor. At the end, we just log how many hamburgers we are going to make, and we process orders by the same way we have seen before. And let's run it. So we run a massive order with 8 people, where each person could ask 3 times, so that's 24, so the first number is correct. But apparently this group wasn't as hungry as they thought, because At the end, they decided to take just 9 hamburgers. And the rest is what we have seen before. And by the end of this story, let's make it perfect, because in reality, it wasn't important at all which appliance was used by which cook. We just needed to make a hamburger as fast as possible, that's it. So when I wanted to heat a bun, I could actually decide which microwave I would use. And of course, I decided to use the one which became available first. Our last experimental declaration for today, select expression, makes it possible to await multiple suspending functions simultaneously and select the first one that becomes available. It works like a when statement, but for channels or different objects. From a bunch of channels or different objects, it selects the first one that is ready. By ready, I mean either channels ready to receive from, actors ready to send, and the first deferred object that becomes with the result. And right now, I would like to focus on actors ready to send, and the rest works kind of by the same way. And now tell me, like, do you want to see the code, or do you have enough of coroutines and you would like to just see the result? It's kind of like 5 minutes more. How do you feel?
Who wants to see the code?
Oh, it's quick. It's quick, but it's difficult. So if you have some energy left, now is the time. But save some for Juraj as well.
Thank you.
So we need to represent our appliances like actors. Let's focus on microwaves and make it clear why. We need to think about microwaves like shared mutable objects, because each microwave is accessible by both cooks, and no microwave can be used by both cooks at the same time. So we need to synchronize this access. A microwave actor suspends while it's heating a bun, which is simulated by delay suspending function. And while it's suspended, it's forbidden to put another bun in the microwave until the one which is currently heating is not warm enough. The message type this actor is going to process is microwave request, which is a simple data class holding a bun which we need to heat, and a channel, which is a communication medium between cooks and microwaves. By using this channel, the microwave actor can let cooks know that the bun is ready. It's like the beeping sound a microwave makes when time is out. On the other side, we wrap both actors in a select expression, which selects an actor that is first ready to send or accept a microwave request. When a request is sent to the actor, we wait for a response, our heated bun, which will be delivered by the channel, and we just return the bun. And now the grand finale. Let's focus on Dominika and her third order. So she cut vegetable, she started frying meat in the first deep fryer, and she started heating a bun in the second microwave. She didn't go on a straight line. Every time she picked a device which was available first. When the meat was ready, the deep fryer let Dominika know that it was done, and the same with the microwave. And with all ingredients prepared, she just mixed them together and she prepared a hamburger. Since that, our hamburger stand was perfectly organized and we were able to feed so many hungry people. And that's the end of our experiment. Just keep in mind that all these discussed types are experimental or obsolete, which means that they can change in the future updates of the Coroutines API. So although they are super powerful, think twice before using them in your project. And this is the link when you can find all code examples, and that's it. So if you have any questions, no questions. So if you want to ask me something face-to-face later, I will be around so we can discuss whatever you want. And that's it. So thank you for your attention. And guys, do you want a break for now? 5 minutes? Yeah? Okay.
Hola a todos. Great to be here in Barcelona, such a beautiful city and awesome people like you. And please, one more round of applause for Ivetta. It's a good presentation. My name is Juraj. I work with Ivetta as STRV in Prague. And today I'll be talking about Vector Drawables. So how many of you are using Vector Drawables in your apps? Well, that's pretty good. And all of you know what Vector Drawables are, like what they're supposed to do, solve, and so on. Okay. I'll just have a high-level thing. Okay, so before, we had all of these folders for icons, for example, in different resolutions. I know MDPI, HDPI, XHDPI, and then more and more axes there. I don't know where it would go. And now Google introduced, to solve this issue, Google introduced Vector Drawables, which is vectors are not based on pixels, they're based on basically functions or curves, so that you can scale them as much as possible from the tiniest ones to the largest ones, and it still looks awesome and sharp. So mostly for icons or like simple shapes. Great. So to see what we'll be doing approximately, or like what we will learn, is some icons like this. So this is the main message I came here to tell you, and that's it. Nope. Okay, I'll try to tell you something more. Okay, so as each presentation has to start with some bullet points. So I will tell you some basic on how to use it as efficiently and as vastly as possible. So first of all, I highly recommend using it with Android X because the previous support library doesn't support all of the functions that are already implemented in Android X, and there was a huge portion of bug fixes from 1.0.2 to 1.0.3. You wouldn't guess it, but it's a really huge portion, especially in parts of back compatibility, like pre-Lollipop devices. So highly recommend that. Then always use Compat, even though if you are targeting, or like your lowest SDK would be Lollipop, but still there were some bugs, so they fixed it in the support library. So please use like SRC, for example, SRC Compat, or the button Compat, or durable start Compat, and so on. There are many of them right now. Great. Another thing to keep in mind is that for pre-Lollipop devices, Vector Drawables can be used for notifications, widgets, and window background, and some other small, but important parts where it's not supported even with the support library. So keep that in mind. And one last thing is that even Android Studio doesn't have the best support yet so far. It happens to me quite often that you get just no autocomplete, just red text, without actually a mistake there, or whatever, which without an error. But yeah, it's getting better, for sure. Great. So just real quick, where to get it? Vector Drawables official website, Material.io, and icons. Or pretty often I do use materialdesignicons.com. It contains all of the official Google ones, and then a community creates basically the same style of icons there as well. Actually fit the same idea how Google wants us to have the icons. Then you can create your own from SVGs or PSDs. and then import them really easily into Render Studio just by importing from SVG and creating a vector drawable. But one last note is to keep it simple, because vector drawable aren't meant for like huge, complicated drawables. They're really like for icons, easy shapes, and so on. So it shouldn't be something like I know if you take a picture of me, it shouldn't be in vector drawables. Right? Like that would be really difficult to make. So, great. How do vector drawables look like? So first of all, they can only be defined by an XML, so you can't create them programmatically. That's the first thing. So you won't see a single line of Kotlin anymore tonight, just XML. And so how does the XML look like? The outermost element is a vector element, and then inside that vector, you can have one path or more paths defining the shapes that you want to have in the icon or in the drawable. And then you can, but you don't have to, group the paths in a group, and that gives you more power over how to transform, for example, the paths that you created. I will talk about it later on, so it's just high-level basics. Great. So, a vector. What do we need to define a vector? So here I have an empty one, and I'll fill it with width and height. Those are mandatory parameters that you have to define, and these are actually used when you use it, for example, for an image view that has width and height set to wrap content. Then these values are used. Any other time, it's just overwritten by what the image view defines. Then you have a viewport width and viewport height, and this is basically the size of the canvas that you are then drawing on. It's like a painting, and you just draw lines there that you'll see later on, but this is the size of it. So this is the kind of like coordinate system that you are moving in. And it's highly recommended that these are like that these two have the same ratios between each other, because then if you don't use same ratios, then the image will look surprisingly squished and either like prolonged in one way or another. Okay, so once you have the vector defined, you can put a path into it. And a path, for it you have many parameters that you can set. I'll just name some of them. They're pretty straightforward to understand and to use, but the main ones mostly used is the fill color. So whatever shape you draw, you can fill it with your color, whatever you like. Or a stroke color. This is basically the line, the outlining line of the shape. And for this, you also have to set its width. And most importantly, a path data, which is first time I saw it, it was just a random stream of numbers and letters, and then I tried to understand it. So that's where it's hiding there, and that's the part I wanna demystify here. So about the path data, there are multiple commands that you can use, and all of them basically define how you move from one point to another point, like a line or a curve or whatever. So there are like 7 or 8 basic ones I want to talk about here, because those are the mostly used ones and the ones that you will come across when you, for example, download the icons from official Google icon store. So the first one is M, and M means move to a point. So you just move to a point and then you start from there. And L is a line. So this one draws a line from where you currently are to a new point where you want to go. So this draws a line to a coordinate X and Y. Then you have a horizontal line or a vertical line. It's basically the same as a line, but it just keeps one of the coordinates constant. Then you have a Z. What Z does is whatever path you draw, then it just closes the path and goes to the beginning with a straight line, and you just have an enclosed path that you can, for example, fill with color. Then you have more like advanced ones, I would say, but those are the nice ones. Bezier Curve. Well, I'll talk about it later on, but it's kind of like this kind of shape that you can create different curves with it. Then you have a smooth Bezier curve. This is basically if you are chaining more Bezier curves, then you can you don't have the transition between them isn't like jagged. It's always smooth so that it looks really nice and sweet. And then last but not least is an arc, which is basically a part of an ellipse going from one point to another, defined by a couple of variables. Great, so let's go through them one by one in detail. First one is the M, which, as I mentioned, was moved to a point, and you always define where you move where you want to move to, so X and Y coordinates. So here I have the canvas with size of 24 by 24. And the horizontal axis is X and the vertical is Y, as we are used to in Android. And then this particular command draws this thick shape, like from your perspectives. And so let's go one by one to understand what happens here. So first, we go to the starting point, which will be, in our case, 6, 11 here. 6 is the X coordinate, Y is the Y coordinate. 11 is the Y coordinate, sorry. And now what we do is move to another point, and this will draw a line, and we finish at this point. So this is an easy beginner starter way how to understand like moving from one point to another. Going forward, we can add another one, and here I can demonstrate what happens when you use the M command again. So if you use the M command again, it actually moves to a point, but it doesn't draw the line there. So if you just chain the ones without specifying the M command again, it will just draw the lines. But when you explicitly say, hey, M again, okay, this will start drawing from a new position independent of the old one. So like this, we can draw the horizontal line below the thick shape. Cool. So now I'll demonstrate what L does. Basically, really, just reuse what we have right here. So this is a line to a point, and it's defined the same way like M, or like you also define an X and Y coordinate where you want to move to. And here, with this example, the shape that we drew won't change. But I will explicitly say that that the L will be here, and that will explicitly say that I will want to draw a line from that point to another. And yeah, it's the coolest animation I found in Google Slides. So, so this still doesn't change anything, and for huge success of the animation, I will do it one more time here. Still doesn't change anything. So that's how an L works. It's a straight line from one point to another. Cool. Now let's talk about horizontal and vertical lines. So it's to a point, and for a horizontal line, you only specify the X point you want to move to, because the Y-axis doesn't change, and for vertical, vice versa. And here we can actually see that the bottom line doesn't change on Y-axis, so we can actually shorten how we make the command to draw this line, and just obey the 17, because this doesn't change. So we can change that to just draw a horizontal line to 19 on an X-axis, and just keep the 17 as it is. Cool. Z. Oh, sorry. Z is to close a path. So here, with this example, we can, after the first two lines that we draw, we can close a path, and that will go to to the last, basically, like to the last m position we defined, which was the 611. And now we can, for example, fill it with some color of this choice. Great. We will now move to more complicated ones. This one being a Bezier curve. And a Bezier curve has this kind of signature. It defines, well, it meets 3 couples of coordinates. And I will right away explain how it works. So we'll kind of curve the shape that we had before, like this. And what we define here is, as before, we start at the same point, but then we define so-called handle. And a handle is something that defines which direction the curving will go and how strong it will be, basically, in like simple words. So the longer the handle, the more strongly the curve will be attracted to this the direction. And same we need to define for the endpoint. So that's the second couple of coordinates, and then we define the endpoint here. This looks like quite a magic with the Bezier curve. So like it's not so easily imaginable like how exactly it will look like. It's kind of a function. So I was actually curious how it works. So I went on the internet, looked it up, and and found an example how it works. And I found it, like, as my geek mind, I found it really interesting. So I wanted to share it with you. So here it is, how a Bezier curve works. I don't know how many of you know how a Bezier curve works. Okay, great. Girls, yeah, thank you. Great. Okay, just Theo. So I can surprise you a bit, maybe. Okay, so these are the two handles we have, and the curve there. And we'll just add one like auxiliary line here, and we'll call the points A, B, C, and D so that we are on the same page, like what we are doing here. And what we'll do next is should wait for the animation. Yeah. So we go from AB to BC along the lines from 0 to 100% of distance, and we'll connect these 2 points, and this will create a line. That's the purple one. And then we do the same from BC and CD. So this will create 2 lines. So we have like a new base where to what to work with. Then what we do next, along these 2 lines, we do the same. We draw a line that goes from 0 to 100% along its path, and this will create the pink-ish, I don't know, pink, let's say. And if we then move a point along this line, what the point does is actually, this is the trajectory that the point travels, is where the curve will be drawn. So it was pretty fascinating for me, so hopefully you find it as well. It's great. So we can move on to smooth Bezier curve, which is kind of like simpler way of defining a Bezier curve, and more smooth from the name of it. What we've already learned, I hope, is how to create a Bezier curve, and then if you want to continue smoothly to another Bezier curve, then you would use the S command. So for the S command, you don't specify the first handle, you only specify the second handle, and then the endpoint. It still works the same, but the first handle is calculated based on the second handle of the previous one, and that way, as it is mirrored, then the transition is really smooth between those 2. So that's like a simplification of it. And now the last command to talk about is the arc, and it is a rather interesting signature here. So the show it on an example once again. So we start at a point, and then we define the radiuses along the x-axis and along the y-axis. So in this case, it will be 7 and 5. Then the next parameter is an angle and 2 flags. I will talk about those later on. I just leave it at 0 for now, so it's at default state. And the last 2 will be where we finish. So that will be the end point. Great. So to explain how an angle works, I created this like half ellipse, and then just for the purpose of showing how it works, I created a whole ellipse. So just to complement it with this particular command. So this is the red one, and then if we create the exact same shape with a rotation of 45 degrees, this is what happens, and it's rather surprising to me, and I can't explain it really well. It's just a mathematical function that basically doesn't just rotate it, but just like squishes it as well. For me, this means it's really rather difficult to predict how it will behave and how to use it. So frankly, I always, when creating paths that I'm not specifically rotating from 0 to 90 degrees, for example, like smoothly, then I always use the rotation of 0, because it's the one that is easy to imagine how the result will look like.
It looks like it's tilting the axis.
Yeah. Yeah. Yeah, that's true. So, but I would say the result isn't that easy to imagine. Like, if you want to have a, I don't know, like symmetrical shape. Great. So, last thing to explain about the parameters is the flags that I mentioned. Those can only have 2 values, 0 or 1. So it's really like a Boolean flag. And you might have noticed that having a start point, an end point, and a 2 radiuses gives us actually 4 options how to move along an arc from one point to another. So this is where the flags come into play. It's called large arc and sweep. Based on how you set the values, all 4 combinations will create one of the shapes. I changed, I made them the color that they represent here. So yeah, guess that's pretty self-explanatory how it works. Great. So for now, all of the comments I've used were uppercase. And yes, it does make a difference if you use uppercase or lowercase. So uppercase means that you move from one point, that you have like the absolute point to another absolute point. If you want to use relative, you use lowercase. And this moves from one point by this much along x-axis and this much along y-axis. So it's not to a relative point. So really a couple quick examples of how it works. For example, for an M, if you want to have the same result, you would move from 6,8 to 10,5 by moving actually by 4 along x-axis and by -3 along y-axis. And I've put in a couple more examples that basically follow the same principle here with L and also with horizontal and vertical commands. Z, easiest one, doesn't change anything because there's nothing to change there actually. Just close the path as it is. Then you have the Bezier curve, which all of the handles, both of the handles and the endpoint are also defined in relative coordinates. The smooth Bezier curve, same story, so I haven't even bothered with an example. And an arc is only affected by with the end coordinate, and the radiuses and the flags you have to redefine again those aren't affected by the relative comment. Okay, so those were all of the commands that are like mostly used or can be mostly seen. And now if you have a group, so you put a path into as a parent of the path, you create a group. You can have even multiple paths within the group. There's a really handy way to make a huge benefit of it once you already have an icon. So you, for example, can already the existing path, you can scale it, you can translate it, which means you move it from one point to another, or you can rotate it, and for the rotation you also can pick around which point it will be rotated. So best shown on an example, right? So here I have a plane, so already a created icon. It's not super difficult to create, but it's been some work. And now I need to rotate it by 45 degrees. Normally, like moving all of the points, calculating all of the lines, where the points should be, that would create like a long floating numbers and so on. So what I want to do instead is just rotate it by 45 degrees, and the result will be like this. Easy. 3 lines of code. Here I'm working on a canvas of 24 by 24, so like the pivot was in the middle, so I just rotated it around the middle. Now, if I want to scale it, for example, it will be again difficult to recalculate, but here I'll just put a scale of 0.5, and it's easy. Then if I want to move it to some other point within the canvas, I can do it easily again with translate, and this moves it by 5 along x-axis, by 5 along y-axis. That's it. And yeah, that's it. So hopefully now you know better how to love beer or how to create these kind of icons. And if you, oh yeah, I have one more thing to show off with. This is something I created with animated vector drawables. So I spent the whole weekend on it. But these are kind of the possibilities that you can actually do with animated vector drawables, which I find really cool. And now, if you have any questions, then feel free to ask. Can I remind you? It's the question time. Oh yeah.
You do your vectors like this, or do you use some kind of program?
I actually enjoy making them from scratch. Once I learned it, I started enjoying it making from scratch. But yeah, there are editors that can help you like edit them in more visual way that's easier to understand.
Inkscape, for example. Inkscape being a free open source editor.
Yeah. There's a suggestion that an Inkscape is an open source free editor for this. Any other questions? Yeah.
Since I struggle a lot with the vectors, they usually give me the vector from Illustrator, Inkscape, everything. Actually, we have a bit of problems because they never turns out like it should be. I think because we didn't use Android X, that you say that they improve a lot. Maybe I can try again with Android X.
Okay, so the question was that the vectors were exported from Illustrator, right? And they didn't turn out to be the way it was expected. This is an issue, like maybe try asking your designer to export it in the least detailed way. I'm not quite sure how it's called, but there are a level of details of how often a point is made along a line when you create it in Illustrator. And there's this setting of like the lowest one, so this will create as few points as possible. And then it's much higher probability of it turning out right. But there still can be some artifacts. And this was basically my whole motivation why I started looking into vectors, because of these artifacts that I wanted to just get rid of without the designer.
One of the issues I remember last time I had to fight with this was, I think it was there is a field type or something like this, I don't remember the exact parameter, which is odd even.
Yes.
And this one was not supported, I think, or odd even was the one that was supported, and there was another one which was quite common, and it made some icons completely filled instead of hollow and things like this. So this was one of the big issues. But I don't know if it's already fixed in Android X.
Yeah. So the question was that there with a fill type using either even odd or none. There was an issue for pre-lollipop devices. I think I remember that one, but I'm pretty sure it was already fixed with a new Android X support library.
I haven't checked with Android X, so
Yeah, yeah, it definitely works much better there. There are actually like cool things you can do with Vector Drawables as well. There, it supports gradients somehow, and yeah, so that gives you more possibilities. Also, you can. As a fill color, you can set a state list, so you can actually have it, like for example, clickable, or have different states of the view, and it will. You don't have to create multiple shapes just with different colors, but you can also already have the state list and set it as a fill color to the vector drawable, and works pretty nicely. So yeah. Yeah, if you don't have any other questions, then thank you very much for coming. And pleasure.